Hi, y'all. So this particular little mini lecture is about kinematics in the y direction. So what happens when we've got motion in the y direction instead of in the x direction? And also just an introduction to free fall and what that is, what that means. So this first slide just shows our kinematic equations. These are, what we've been using or what we used the other day in class to figure out some problems with motion in 1D. So how would these change if we were to apply them to the y direction instead? Well, don't blink. Okay, there they are. So what changed exactly? Well, wherever we saw an x, now there's a y, and that's it. It's that simple. Now, next chapter we'll study things like projectile motion. That's maybe somebody jumping, up in the air in an arc. Picture a long jumper, something like that. Balls that are thrown. I don't know. Honestly, we could look at bird in flight too, but that's not projectile motion, and we tend to stay away from that a little bit. But we could study that as well. All those have the idea in common that there's motion in x and in the x direction and in the y direction. So it might be a little more useful to maybe make sure we know what velocities and accelerations we're talking about if we've got motion in x and y. So it might be useful to add some subscripts in there. So you see wherever I have a velocity or an acceleration, I've just added a y subscript just to make sure that I understand that I'm talking about velocity in the y direction or acceleration in the y direction when I'm trying to apply these kinematic equations for y motion. And I would do the same thing if I were dealing with x motion. I would apply x subscripts instead. All right. So anytime I've got an object that's been thrown up in the air or whatever, and it's not under its own propulsion, it's not like I don't have like a jet engine, I don't have like a bird flapping wings or something like that. The only thing that's acting on that object is gravity. Then that object is said to be in free fall. So this neglects the idea of air resistance, which is fine for most things that we're going to deal with. So neglecting air resistance, if the only thing that's acting on an object is gravity, it's said to be in free fall. Does that mean that necessarily that the object is dropping? Well, no, the object could be actually traveling upwards, ball thrown up in the air. The only thing that's acting on that ball after it leaves my hand would be gravity. And in that case, it's said to be in free fall. Now, the acceleration due to gravity is always downwards towards the earth. So the acceleration due to gravity, we typically think of as being negative. Why? Because we typically make upwards a positive direction. Gravity is going to have a size, a magnitude that's equal to 9.8 meters per second squared. So that's the actual size of the acceleration due to gravity. But if I'm talking about the acceleration itself, I would say that the acceleration is negative 9.8 meters per second squared. So if I were to actually write in what the acceleration of something in free fall is in the y direction, that would be negative 9.8 meters per second squared. There we go. All right. So let's take a look at maybe an example here. We've got the upwards direction is positive, the downwards direction is negative. We can picture a ball being thrown up in the air, hitting a turnaround point, and then coming back. Or ball being thrown up in the air, slows down, gets up to its peak, and then falls back down. What's happening there during its flight? So initially, well, what's going on? It's slowing down. So gravity is acting downwards on it. It's causing the ball to slow down as it rises. Then when it gets up to the top, its velocity is 0, but gravity is still acting on it. It still has an acceleration that's downwards due to gravity. If it didn't have an acceleration downwards, then it would just hang up there in the air. That doesn't happen. So no. It's changing directions up to the top, going from positive to negative, positive velocity to negative velocity. Up at the top, it's got 0 velocity, but it's still got an acceleration that's pointed downwards. Always has an acceleration pointed downwards, negative 9.8 meters per second squared. All right, and there, as it's falling, what's going on? It's speeding up and moving downwards. All right, so magnitude is always 9.8 meters per second squared. Direction of gravity is always downwards. So A would be equal to negative 9.8 meters per second squared. All right. There's a cool little video here that I think I'm probably going to try to do in class rather than play it over the computer and risk all kinds of hazards there. So I'll try and mess this up tomorrow instead. All right. I will see you then.